Good morning, my dear boys and girls. I hope you're all quite well. Once again, I'm telling you, take care of your health and kindly watch all the videos uploaded by your teachers. So, my dear children, in the last video session, we have completed the metallurgy chapter. So, one lesson has been completed, and today we are going to start the second chapter, that is P block elements 1. And in P block elements, we are having two chapters. One is P block element 1 and the third chapter is P block element 2. So it was divided into two chapters. So in the first chapter, we are going to study about the P block elements 1. So already you studied about the periodic table, periodic classification of elements. You studied in 11th standard. So just we'll recall a little bit about that periodic classification. You just see the picture. So actually elements are classified into 4 blocks, namely S block, P block, D block and F block. Already you know these informations. And the first two group is called as the S block, that is in the left hand side. And on the right hand side from 13 to 18 it constitutes the P block element. And the center one, that is 3 to 12, it constitutes the D block element, and below the periodic table that is called as the F block elements. So this chapter we are going to study about the P block elements. So you just see the picture. So in that from 13th group to 18th group is called as the P block elements. So P block, the 13th group is boron, and the 14th one is carbon family, and the 15th one is nitrogen family, and the 16th one is oxygen, 17th one is fluorine, and finally the 18th one is helium. Okay, these are the first elements present in the 13th to 18th group. So in the P block element, it contains metals, non-metals as well as metalloids. And non-metal elements are completely different. It has a different property when compared with the metals. And you know, some elements, it plays an important role in our daily life. That is, for example, if you take oxygen, it plays an important role in our life. Without oxygen, you can't able to live. You can't able to survive. So one of the most important element is oxygen, and that oxygen, it belongs to this group. And aluminium. Actually, in the first lesson we studied about the uses of aluminium. It plays a very important role. That is, from the household utensils to aircraft, aluminium is used. Aluminium and its alloys are used. So this is also very important element, and that element, it also belongs to the P block. Then some of the semiconductors like silicon, germanium, these two elements also, it plays a vital role in the field of modern electronics, in the electrical field. So that elements also belongs to this P block. So such important elements are present in P block. Next we are going to study about the general properties of P block elements. Next we will study about the electronic configuration and its oxidation state. So the P block elements, it has the general electronic configuration Ns2Np126. So already you know this. The last electron, it enters into the P block, therefore it is named as P block elements. So all these, that is from 13 to 18, the final last electron, it enters into the P block. Okay. So if in this, the group 18, that is inert gas, it has completely filled orbital, that is, it has the configuration Ns2Np6. So it was completely filled, and therefore that elements are highly stable, and it has very less reactivity. Because it is completely stable, we can't able to remove the electron and we can't able to add the electron. Now you just see the picture. See in that group 4 from 13 to 18, its group name, outer electronic configuration, highest oxidation state, and the observed oxidation states are mentioned in the picture. So 13th group is called as icosargens, 14th group is called as tetragen, 15th one p-nictogen, 16th one chalcogen, 17th one halogen, and the 18th one is inert gas. Now come to the oxidation state. The 13th group, the highest oxidation state is +3. Just see the configuration, it is Ns2Np1. So totally 3 electrons are there in the outermost. Therefore, the highest oxidation state is +3. And in the 14th group, it is +4. 15th group, it is +5. And 16th one +6, 17th one +7, and 18th one is +8. This is the highest oxidation state. So other oxidation states are also mentioned. For the first one, the outermost is only 1 electron in the 13th group. Therefore, the observed oxidation state is only +1. Then coming to the next one, the outermost is Ns2Np2 for the 14th group. So therefore, the observed oxidation state is +2 and as well as -4. That is, it can gain electron or sometimes it can lose electron. Then for the 15th one, it is +3 and -3. Then for the chalcogen, it is +4, +2, -2. And in the halogen, see, just consider the negative oxidation state, it is -1. So most probably halogen can able to form -1. And inert gas, it is +6, +4 and +2. So these are all the oxidation, various oxidation states of the elements present in the group 13 to 18. Next, we'll see about the metallic nature of the P block elements. So kindly observe the picture. So from the picture itself, you can easily understand various colors was given in the picture. And already you know the concept of ionization energy and the metallic character. You were studied in 11th standard. So when you move from top to bottom, that is group wise, from top to bottom when you move, its size will increase, whereas the ionization energy will decrease. So once the ionization energy decreases, its metallic character increases. So already you know the concept ionization energy. What is ionization energy? It is nothing but the amount of energy required to remove the most loosely bound electron. So if you see the group 13th one, so boron is very small and the thallium, the last one, it was very large. So which has the smallest size will need more amount of energy because of the nuclear charge. So these concepts already studied. So the main thing, you just keep it in your mind. If the ionization energy decreases, its metallic character increases. So when you move from boron to thallium, boron is the only element which is a metalloid. Therefore, it is mentioned in green color. And the remaining elements, it is aluminium, gallium, indium, thallium, and these are all metals. So if you see the picture, the lower left part, which is blue in color, and these are all the lower left part are metals, while the elements in the upper part are non-metals. And in between, green color is given, and that is referred as metalloids. So in the group 13, boron is the only element which is a metalloid. Next, come to the 14th one, carbon is considered as non-metal. And silicon and germanium is a metalloid, whereas tin and lead is considered as a metal. And come to the 15th one, nitrogen and phosphorus are non-metals. And arsenic and antimony, it is a metalloid, and bismuth is metal. Next, 16th group, oxygen, sulfur and selenium, non-metals. And next one is tellurium, which is a metalloid. Then in 17th group and in 18th group, all the elements are non-metals. Because already you know 17th one is halogen and the 18th one is inert gases, and everything, all the elements present in 17 and 18 are non-metals. So these are all the metallic characters of P block elements. Next concept is that ionization energy. So already I gave you the explanation for the ionization energy, and already you know that there is a steady decrease in the ionization energy of elements due to the increase in their atomic radius. That is the general trend. So when you move from top to bottom, the atomic radius increases, and therefore due to the increase in their size, the ionization enthalpy decreases. So if you see the picture, actually in the picture group 15 is given. So for that, when you move from top to bottom, the ionization energy decreases. That is from 15th to 18th group, these elements will have the ionization energy decreases as we move down the group, because here it has a poor shielding effect of D and F electrons, which will overcome the increased shielding effect of the additional P electrons. But when you consider the 13th group and 14th group, there is a marginal difference. There is no steady decrease in that. Now see the picture of 13th group element. See, in the 13th group, the ionization enthalpy, it does not decrease. There is a marginal difference. Why? What is the reason behind it? Because this is due to the presence of inner D and F electrons, which has very poor shielding effect when compared to the S and P electrons. So because of the poor shielding effect, already you studied the shielding effect also. So when there is an electron cloud, if the electron is more, it has more shielding effect. But here the electrons, there is no shielding effect. So that is the reason for the marginal difference. As a result, the effective nuclear charge on the valence electron will increase. So therefore, there is no steady decrease in the ionization enthalpy. Whereas when you compare the 15th group, 16, 17, 18, and these group elements will have the steady decrease in the ionization enthalpy, because the poor shielding effect of D and F will overcome by the increased shielding effect of the additional P electrons. Yeah.